Have you ever wondered what our solar system looked like in the past? Were the planets the same as they are today, or were they completely different? In this video, we will travel back in time to discover how the planets looked 3.8 billion years ago. Before we begin, remember to subscribe to the channel and hit the bell icon so you don't miss any new videos. Now, why did we choose 3.8 billion years ago? We chose this specific date because during that period, the solar system was coming to the end of an era known as the Late Heavy Bombardment period. This period occurred between 4.1 and 3.8 billion years ago. In this relatively brief time on a cosmic scale, numerous asteroid impacts occurred on the planets and objects within the inner solar system. Let's start with the gas giants. The gas giants have not changed much throughout their history because they do not have a solid surface. For this reason, during the Late Heavy Bombardment period, Jupiter, Saturn, Uranus, and Neptune underwent many asteroid impacts that sank into their clouds, leaving their appearance unchanged. Some astronomers believe that Jupiter and Saturn may have slightly changed color due to the minerals deposited by the asteroids, but only very subtly. This was deduced from the impact of the comet Shoemaker-Levy 9 on Jupiter in 1993. The comet deposited large quantities of material on Jupiter's surface, creating a powerful dark vortex that slightly altered the composition of its clouds. Aside from this, it is very likely that the gas giants looked the same as they do today. However, this does not apply to their moons, which were probably not as numerous as they are today. For example, Neptune captured its largest moon, Triton, at a later time. With the gas giants clarified, let's move on to the rocky planets, which were completely different. Starting with Mercury, 3.8 billion years ago this planet looked like a lava pit after the end of the Late Heavy Bombardment period. Analysis from the MESSENGER probe has shown that Mercury's surface, like that of the Moon, has numerous impact craters, some of which are relatively recent and characterized by a central peak. The older craters have undergone extreme erosion, possibly due to the significant temperature fluctuations, ranging from 350 degrees Celsius during the day to 170 degrees Celsius at night. Mercury seems to have undergone a period of intense bombardment by large meteorites about 4 billion years ago, during which it received numerous impacts across its surface, facilitated by the absence of a significant atmosphere that could disintegrate or slow down many of these rocks. During this period, Mercury was volcanically active, forming basins and depressions with lava from the planet's interior and producing smooth plains similar to the Maria on the Moon. The MESSENGER probe discovered possible volcanoes on Mercury. Mercury's plains have two distinct ages. The younger, less cratered plains probably formed when lava flows buried the previous terrain. A characteristic of this planet's surface is the numerous compression folds that cross the plains. It is believed that as the planet's interior cooled, it contracted and the surface began to deform. These folds are visible above the craters and plains, indicating that they are very recent. Mercury's surface is significantly influenced by the tidal force exerted by the Sun. The tidal forces on Mercury are 17% stronger than those exerted by the Moon on Earth. A notable feature in Mercury's geology is the Caloris Basin, an impact crater that constitutes one of the largest meteoric depressions in the entire solar system. This geological formation has a diameter of about 1,550 kilometers. Before the flyby of the MESSENGER probe, its size was thought to be 1,300 kilometers. It also has a shape of unknown origin never seen before in any other crater on a celestial body. At its center is a crater, but it is not known whether it is related to its formation. All this shows us that Mercury had a very violent past, and it is likely that it did not look the way it does now, because due to the numerous impacts of meteorites and comets it was a sea of fire much hotter than it is today. Venus has sulfuric acid rains and temperatures exceeding 480 degrees Celsius. However, it has not always been the hellish place it is today. In fact, all analyses show that very likely, billions of years ago, Venus was quite similar to Earth. After the period of meteor bombardment, several comets fell on rocky planets, including Venus. Comets, being vast bodies of ice and the largest reservoirs of water in the solar system, deposited water on the planets. If the planet had sufficient gravity and an atmosphere, the water could remain and create oceans, lakes, and rivers. It is believed that in the past, Venus's climate and atmosphere were more temperate, with temperatures reaching 50 degrees Celsius, much friendlier compared to the current 480 degrees Celsius. With these temperatures, it is possible that Venus had oceans filled with water like Earth, as well as having all the conditions to host living beings for at least 300 million years. Venus could retain all the water deposited by comets and had a much richer atmosphere in carbon dioxide. However, eventually, something happened that caused more and more carbon dioxide to accumulate, gradually heating the entire atmosphere and evaporating the water until it disappeared completely. Over the years, the planet heated up and trapped greenhouse gases, causing it to stop being a friendly and quiet planet with water. Venus has a greenhouse effect that prevents heat from dispersing and traps gases, heating its surface and preventing the formation of any form of life. Earth, undoubtedly the most diverse planet, has not always been our beautiful and peaceful blue home with oceans and forests full of abundant life forms. 3.8 billion years ago, after the late bombardment period, Earth looked very different. At that time, our planet was at the beginning of its Archean period. During this period, the evolution of the Earth's crust occurred, with the formation of plate tectonics, plate movement, and an internal Earth structure similar to what we know today. However, it differed due to the excess heat. It is estimated that there was greater seismic activity due to the incredible speed at which the lithosphere was produced, so one would expect greater activity at oceanic ridges. Underwater elevations formed due to plate tectonic movement. During this period, there was more significant activity in subduction zones and a greater number of plates, causing constant earthquakes across the planet. There were volcanoes everywhere and a higher concentration of greenhouse gases in the air, especially carbon dioxide. The atmosphere lacked oxygen. Temperature seemed close to current levels even 500 million years after Earth's formation, with the presence of liquid water. Astronomers believe the Sun was about a third as bright as it is today, which may have contributed to lower global temperatures. It is thought that during this period there was the highest volume of greenhouse gases at any point in Earth's history. During this period, stromatolites, important fossils resulting from the activity of groups of cells in colonies that formed sedimentary rocks, formed. Stromatolites began to form 3.7 billion years ago, with a peak abundance of 1.25 billion years ago. Scientists discovered that these organisms consumed carbon dioxide and turned it into oxygen. In other words, they were responsible for filling our planet with the oxygen we breathe. As you can imagine, billions of years ago Earth did not yet have the conditions to host living beings like those of today. In fact, it is likely that few of the living beings that exist today could survive the conditions our planet had at the time. Finally, we have Mars. Scientists believe that in the past Mars resembled Earth a lot because, after the late bombardment period, it received the impact of several comets that filled it with water. For this reason, Mars had a much denser atmosphere than it does today, as well as much more pleasant temperatures. It also had oceans and rivers filled with water, all the conditions to host living beings. Exploration probes have found traces of what appear to be water currents that once existed on the red planet and have also discovered small deposits of water mixed with sand or clay beneath the Martian surface. Undoubtedly, in the past, Mars was a much more hospitable place for life, and that is why many scientists think that life may have originated there and then migrated to Earth through asteroids, according to the panspermia theory. Mars was for many years the most hospitable planet for life. It might have even been more hospitable than Earth. However, its core is tiny and cooled very quickly, causing it to lose its magnetic field. Without a magnetic field and with weak gravity, there was nothing to protect the atmosphere from solar radiation. Eventually, the solar wind gradually stripped away Mars' atmosphere, decreasing atmospheric pressure, causing the water to evaporate and disappear from the planet until it completely dried up. As you can see, over the course of history, the planets have undergone significant changes that have led them to be what they are today. Yet, thanks to these changes, one planet managed to gain the conditions necessary to host living beings. If we have learned anything from studying the past, it will help us understand what the future will be like. Today we know that Earth and the other planets continue to evolve and that our planet will not forever be the hospitable home it is today. Therefore, we must take care of it and protect it until we find a new home on some other planet in the universe.